Here we go. Greetings, junior scientists, and citizens of the great, big, weird, wild, and wonderful world in which we live. As always, I'm your humble science communicator, the great Orbax, coming to you from the Department of Physics here at the University of Guelph. I'd like to welcome you to our March 2026 stargazing guide. Well, it's March, and while it may not quite seem like it yet, this month brings with it the first day of spring. Sunrise moves from 6:57 a.m. on March 1st to 7:04 a.m. on the 31st, but sunset moves from 6:10 p.m. on the 1st all the way back to 7:47 p.m. on the 31st. This may seem anomalous, but remember, daylight savings forces us to spring forward by an hour on March 8th. So what should we expect from our March night skies? This month, we're desperately seeking Saturn, look skyward to a full warm blood moon, and learn what the vernal equinox really means. All this and more when we just take some time to look up. We've got a lot to get to this month, but I wanted to talk planets for a little bit first. For most of the winter months, the gas giants Saturn and Jupiter have been easy to spot. That said, you may notice this month Saturn just kind of disappears. This is due to something called solar conjunction. We've mentioned this in the past when we've talked about NASA engineers being unable to contact our rovers on Mars. Solar conjunction means that the sun is between Earth and another planet, effectively blocking our communication with this planet, but also our view of it. This is the case with Saturn this month. On March 25th, it'll be at solar conjunction, and around that time, it will also be at its most distant location from Earth. But fear not, come April, Saturn will return to our view, only this time, it joins us in the hours before dawn. Our full moon this month is on March 3rd, and is known as the worm moon. As we approach the first day of spring, the ground thaws and our annelid friends make their way to the surface, providing food for the returning birds. The Cree and other northern indigenous people refer to the moons around the equinox in terms of these birds, while the Mi'kmaq of the eastern coast have their moon cycles begin later in the calendar months. So this early March moon is the Buganajit, the snow blinding moon. Actually, this month we not only have a full worm moon, but we have a full worm blood moon. That's right, a total lunar eclipse will take place in the hours before sunrise on March 3rd. The last time we saw a total lunar eclipse was March last year, but we won't see another one until 2029. So what exactly is a lunar eclipse? Now you're likely familiar with a solar eclipse like the one we saw in April of 2024. A solar eclipse occurs when the moon passes between the Earth and the sun. Well, a lunar eclipse occurs when the moon actually falls into the Earth's shadow. But the moon appears to move between the sun and the Earth during new moon, and is opposite the Earth and the sun during the full moon. So why don't we have eclipses twice a month then? Well, it's actually a little bit more complicated than that. The plane of the moon's orbit around the Earth is actually tipped at 5 degrees with respect to the Earth's orbit around the sun. This means that even though we have a full moon, the moon doesn't always line up in the Earth's shadow. But at least twice a year it does. And that's when we experience a lunar eclipse. So then what's the deal with it turning red and calling it a blood moon? The Earth's shadow has two distinct parts. When the moon passes into the Earth's penumbra, this faint shadow darkens the moon slightly. When it passes into the umbra, the moon will briefly completely darken and then turn red. At this point, we have a total lunar eclipse. But why red? As the sun's light passes through the Earth's atmosphere, it scatters. This results in shorter wavelengths like blue light being diverted away from the moon, whereas the longer wavelengths like red light are what bathe the moon. As a matter of fact, if you happen to be standing on the moon during the lunar eclipse, you'd see a red ring emanating around the Earth, which is all that remains of the light escaping Earth's atmosphere of all the sunrises and sunsets taking place on the edge of the Earth. Now, unlike a solar eclipse, it's perfectly safe to look at a lunar eclipse with the unaided eye, binoculars, or even a telescope. Now, this eclipse will occur in the hours just before sunrise. So here at the University of Guelph, we should be able to catch totality just before the sun peaks up over the horizon. But other parts of North America, to the west, should be able to see the entire eclipse. The moon will enter the Earth's penumbra and start to darken at 3:45 a.m. Eastern Time on the morning of March 3rd. The total eclipse, when it enters the umbra and turns red, will start around 6 a.m. and reach totality at 6:34 a.m. Now, moonset occurs at 6:57 and sunrise takes place at 6:54. So get out there early if you want to catch the full warm blood moon. Good luck, junior scientists. Now, only a few days later, on March 20th, will be the vernal equinox, or what's commonly denoted as the first day of spring. So this month, we'll see the first day of spring, and here's why. We all remember that the Earth is tilted at 23.5 degrees with respect to the line that's perpendicular to the plane of our orbit around the sun. 1 Earth year corresponds to 1 full solar orbit. Back in December, we talked about the winter solstice, the one day each year when the North Pole is tipped its furthest distance away from the sun, resulting in the fewest daylight hours experienced in the year for us here in the Northern Hemisphere. Conversely, the summer solstice marks the day when the North Pole is tipped towards the sun, resulting in the most daylight hours we experience in a year. On March 20th is the vernal equinox. On this day, halfway between the winter and the summer solstice, we experience equal amounts of daylight and nighttime hours. And in North America, this denotes the first day of spring. This phenomenon occurs again in 6 months when we've passed 180 degrees through our orbit around the sun. We call this the autumnal equinox, and it takes place this year on September 22nd, denoting the first day of autumn. What do you know? And on top of all this, we wait with bated breath to see if Artemis II returns humanity to the moon. So much to see and so much to learn, and all we have to do to take part is just take some time and look up. See you next month, junior scientists, and don't forget to have a science-tastic day.
Special thanks to Royal City Science's own planetary geochemist, Dr. Glynis Perrett, for her help in preparing our stargazing guide.
And the Royal Astronomical Society of Canada